Today's topic is a structure type. So these are today's topics. So first I introduce the structure type and also explain declaration of how to declare for structure type and how to define the such a variable, structure type variables, and how to access or member variable of structure data, and nesting declaration and image of structure type variables. And also I introduced the array type, especially for structure type data. And I also introduced some example program using structure type. And finally, I introduced the exercise. So do you know the structure type? Maybe no. So already I introduced some data type, primitive data type, character type, integer type, floating point and number, and so on, array type and string type. So however, some cases sometimes you want to define the new type, especially for complicated data. For example, as shown here, personal data usually includes name, birthday, age, address, phone number, and so on. So these attributes are defined as a primitive data type. So, however, composition of these data can be defined as special data. It is very convenient in your program. Okay? So, as shown here, complicated data includes several variable types of primitive data. In such cases, you have to define the special structure type data for such data. Okay? So before using structure type data, you have to define the structure type. So this is general form. A structure is a special symbol for structure type. And sometimes you can specify the structure name. This is optional. So sometimes you omit this information. And using these brackets, inside you can define the primitive data as member variables for corresponding structure type data. Okay? So this is the example. So this example is for the point data type, especially for the 2D graphics. So usually 2D graphics has you have to specify the point location of the 2D graphics, 2D coordinates, x coordinate and y coordinates. So you can define such a structure type. Its name is a point. Point is the structure type name, structure name. And inside the bracket, you can define two integer type variables, x and y. The such variables I already explained called member variables. Okay? So in this case, x and y are both the member variable of the point structure data. So after defining the structure type, you can also have to declare the variables. So these are several types of the declaration for variables. So if this structure has two member variables, x variable and y variable. Both are integer type primitive data. So if you don't define such a structure if you don't specify its name for these structures, you can put this data this form directly for structure type to define these variables A, B, C. In this case, A, B, C are all variables, especially for this data type. Okay? So A, B, C variable has X and Y for their member variables, as their member variables. Okay? So if you specify the structure name point, as explained before seeds, you can put point structure name to define to declare the variables for point data. Okay. So this part is corresponding to this name. Okay. And also you have to define the initial value for variables. Okay. So point, as I explained, point has X and Y variables as their member variables. And using this form, you can specify the initial value for X member variable, Y member variables. In this case, X is 320 and Y is 200. Okay? So this is very important. Once you can define the structure type, new structure type, and after declaring some variables for such structure data, you can use such data, structure type data. However, important thing is how to access such member variables for structure type data. As I explained, so this is a definition for the point data, structure data. These are the X and Y as its member variables. And using this form, you can declare the variable PT. This is the variable name. So this type is a point of structure type. Okay? So PT has a X variable and Y variables as its member variables. The initial value is 320 and 200. Okay? After using this form, okay, this is important. PT is a variable name for structure type, and .x. Using dot and member variable name, you can access the contents of these variables. Okay. Also, pt.y, you can access the member variable y of point variables. Okay. So the execution results of this sentence are 320, 200. This string will be appears on the computer screen. Okay. And so also you can use the pointer data type for structured data using the asterisk. So I already explained the asterisk is used for the pointer data type. So if you put the asterisk front of the variable name, so such a variable is treated as a pointer data type. Okay? So in these cases, you have to specify structure point. So this pointer is treated especially for the point data type. Okay? So after definition of these sentences, the point is a structure data type, especially for point structure. Okay? This variable is not pointer type. So however, if you put the and mark the front of the point variable name, you can access the pointer of these variables. So such a pointer using substitution operator, equal operator, you can store such a pointer data, pointer address into this pointer type of variable. Okay? So in this case, pointer PT is not pointer data type. This is an instance itself. And PT2 is a pointer type variable. So PT2 and PT is different. For pointer type data, especially for such data is a structure type, you can also access the member variables using hyphen larger than symbol, like this. Okay? And also you can access Y member variables using this form. Okay? So PT is the instance. This case is you can use dot to access its member variables. If variable is a pointer type for structured data, in these cases, you can use hyphen rather than symbol to access its member variables. Okay? There is the difference. So also you can define the structured data using a nesting. So once you define the point structure type data, using this structure type data, you can also define another structure using this previous structure type. So this case is you can define the rectangle. So rectangle is usually defined by 2 points. Okay? Left top coordinates and right bottom coordinates. So such 2 points are defined using these 2 point structure type data, PT1 and PT2. Okay, so this right top coordinates correspond to this PT1, and this corresponds to this PT2. Okay. So once you define the new structure type data, rectangle, recto, you can declare the variables, a box for such a structure data type. In fact, box has 2 member variables, PT1 and PT2. So such member variables both are also structure data type points. The point also has the X and Y member variables. So you can set the initial value by using this form, box.pt1.x and box.pt1.x. So pt1 corresponds to this point, and x and y is x coordinate and y coordinate of this point. So initial value is 10, 10. And box also has a pt2 as its member variables. So pt2 also has a point structure data. Its member variable is x and y. So box.pt2.x using this form, you can substitute the initial value, in this case 100, 100. Okay? So these sentences, you can specify the new data, rectangle data. Okay? So like this. This sheet shows the image of the physical memory are prepared by the declaration of previous sentences. Okay, so this is the first line is a definition of new data structure, new structure data type. Its member variables x and y. Both are the integer type primitive data. And second line is a declaration of the variables for such a data type, point data. In these cases, in the physical memory of your computer, these two boxes are prepared for member variables, especially for point data type, point structure data type. Okay? So if you substitute 1 and 2 to both x and y, so this box has the 1 and 2 in this way. Also, you can define declare the array data type for structure type data. So this case is this sentence you can declare variable a for array variables. Its element size is 10. Okay, so each element is a structure type data. Such structure is a point. It has a x and y as member variable. Okay, so if you define the structure name point for these structures, you can declare variable a similar to this using the point. This is a structure point. Okay, if you already define the structure name for any structures, after that you can use such a structure name before the actual structure, before using instead of using actual structure. And also you can set the initial value using this home. Okay, so as I explained, the A is the variables, especially for array data. Its element is a structure type data. Its structure is a point. The point has a x and y variables as its members. Okay, so initially you can set the initial value like this. For example, this bracket corresponds to the first element of this array variables A. So first element is also has two member variables x and y. Such values are 320 and 200. The second element also has a point structure, and it has x and y as its member variables. In this case, its initial value is 0, 0. So similar to you can define the all initial values. So instead of using this initial declaration form, using these sentences, you can also set the initial value separately. Okay? So from here, I'd like to introduce some example programs. The basic contents of such program is almost same as those of I already prepare. I already introduced in the several weeks ago. Okay. So first program calculates total sales of the company in each month. Okay. So this case is this company had two branches, West branch and the East branch, and East branch has sales for January, February, March, like this, and also East branch has January, February, March sales, as shown here. And this program calculates total sales of two branches. And calculation results should be like this. So you can use array data for sales of each month. Okay. So each branch has a branch name. So branch name and this array variable are member variables of the new data, new structure type data for each branch. So this is a actual program. First, you can define your new structure type data, name underscore sales. This structure has two member variables. One is its name, branch name, for example, West branch or East branch, and sales. The previous example has a 3-month sales, January, February, March. So this variable is array variables. Okay? So index 0 corresponds to January, index 1 corresponds to February, 3 corresponds to March. Okay? And once after defining this new structure type data, you can declare variables for this new structure type data using these sentences. In this case, two variables declares the company variable and branch variables. Especially this is declares array variables because this company has two branches. Okay? And also integer type data variable month and b. So first, using a string copy function, you can specify the name for each branch, West branch and East branch. Okay? And branch 0 corresponds to the West branch, and branch 1 corresponds to the West branch. So their name should be West and East. And also using string copy function, you can also define the company name, KU, for example. And initially, you have to define the each month sales for both branches. So this is a West branch, correspond to West branch and the East branch. Okay? So 0 corresponds to the West branch and 1 corresponds to East branch. And sales 0, 1 to correspond to the January, February, March, respectively. Okay? So using this for loop sentence, you can calculate the total sales for companies. Okay? So using a plus equal operator. Okay? And finally, this program outputs results on a computer screen. So next program is also the same program I already introduced. This program calculates deviation of the student examination score. Okay. So this program treats student name beside their scores. This is different from the previous program I already introduced. Okay. So you have to define this data as a structure type data. Student name and the student scores. So variable, member variable should be name and score. Name is a string. Its character size is 5. It's enough because usually 2 characters. And score as integer type numbers. Okay. So and structure name is a name underscore score. And this case is there are 10 data. So using these sentences, you can declare the variables for structure name underscore scores. So each size is 10 as arrays data. So this previous program has to calculate the deviation of each student. So using this expression, you can calculate deviations. So you have to, before calculate this, you have to calculate average and standard deviations. Average, you can calculate like this. And also, you can calculate standard deviation using these expressions. Okay? So in this case, M is corresponding to average. So DI is each score of the student. So this is a complete program for previous. So as I explained, you can define the name underscore score new structure type data for student name and student score. And this is the initial declaration for variables. As I explained, this program treats the data as its variables, especially for array data. Okay. So as I explained, you can define the initial values using this form. Okay. So this is the first element of data variables. Okay. So each element has name underscore structure type data. So its member variable name and the score. So D corresponds to name and 0 is correspond to the score for first student and second student, third student, fourth student. Okay? So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 data. So maybe this is a take a mistake. So total number should be 10. So however, this declaration declare that 11 data. So I took a mistake. Should be 10. Okay. And the following is almost the same as the previous program I introduced several weeks ago. So using for sentence, you can calculate the total score, and by dividing the total number of students, you can calculate the average. And also using for sentences and square root for 2 divided by n, you can calculate standard deviation. Okay. So using standard deviation and average, and using these sentences, you can calculate the deviation for each student. So next program is for displaying the bar chart. Okay? For several students' data. So each student has a name variable, member variable, and data. Okay. So maximum data size is 100. And using this sentence, you can declare the variables, array variable D for at most 100 data, especially for name underscore data. As I explained, this has a structure like this, name and data as its member variable. And so using these sentences, you can enter several data. Okay? One by one, its name and the data. Using these sentences, you can display the bar chart represented as asterisk. Okay, so anyway, please try to make this program and execute to check the behavior of this program in the today's exercise later. So fourth program is a sorting program. So several weeks ago, I already introduced bubble sort algorithms. Okay. So, however, this case is each data has a student name and his score. Okay. And in this case, the initial value as shown here, 6 student data, student name and score, second student name and score. Okay. So using this structured type data, name underscore score, its variable, member variable is the name and the scores. You can treat this kind of data. Okay. So this part is a bubble sort algorithm part. So in fact, this includes some errors. In fact. So anyway, please try to make this program and execute to check the behavior of this program. So do you know any errors include these sentences? So later I will ask the correct program. I will answer the correct program. So finally, this program to put sorting results using these sentences. So today's content is that all. And as shown here, please try to make a program I introduced today and execute its behavior. Okay? And the remaining time, so please spend for making reports for the previous, or if you don't submit, not yet. So do you have any question? Okay, so please try.